Hello and welcome to this lesson about equivalent expressions. The learning target for this video is learning how to recognize and make equivalent expressions. Now to start things off, let's address the big question. Why does this matter? What's the point of learning about this? And learning about equivalent expressions, it's really about being creative. It's really about being able to manipulate. So creative and being able to manipulate. And the best analogy I can come up with is using Legos. So consider this picture down here on the left. Let's say you're doing something with Legos and you need a piece that's 4 by 2. But man, you can't find a 4 by 2 piece. What can you do? Well, you can get creative and be like, all right, I'm going to use a 3 by 2 piece and a 1 by 2 piece. And you rotate it, you can make that a 4 by 2 piece. Or you could take two of these guys and do the exact same thing. Equivalent expressions is all about being able to be creative. What do you have? How can you rewrite it? How can you change some of the numbers? How can you manipulate it so that it can serve your purpose? And so these are skills that might seem kind of, boring and might not seem that significant now, but later they play a significant role in being able to do more math. All right, so let's talk about what helps us find equivalent expressions, and it's properties. Properties help us do that. There's a handful of them that we'll talk about. There's 4 specifically here. You have the commutative property, so commutative. You have the associative property. You have the distributive property. Distributive. And finally, you have the identity property. And so what we're going to do is take some time and go over each of these properties in a little more detail and make some analogies. So that way, hopefully, they really it sinks in and you remember what these are. So the commutative property, take a look at the word commutative. And if we just kind of maybe got rid of that A and made it an E and got rid of the rest, we have the word commute. And commuting is going from point A to point B and back to point A. So I love to use the idea of cars for this. The commutative property is where you can switch things around. You can move them from their places and they have the exact same value. So we put a plus sign there and then we move these. We haven't changed the value of the expression that we have. It's got the exact same value. And so that's the commutative property. A plus B is equal to B plus A. And at the same time, you could do it with multiplication. A times B is equal to B times A. And if you don't believe me, let's use some numbers. 5 plus 3 is equal to 3 plus 5. You have 8 is equal to 8. So it's the same thing either way. Same idea with 5 times 3 is equal to 3 times 5. 15 equals 15. Next property, you have the associative property. Now, the associative property, you have to take a look at associate, or this first part, associate, and think about, that's how you, or who you associate with, how things are associated together. And so you're really thinking about a group. How are you grouping things together? So grouping, that's what that word is trying to spell there. There we go. Grouping is what it's all about. Okay, so this picture shows a little bit of age. Bear with me. Okay, I get it. Kevin Durant's not with the Warriors anymore. And if you were going to put 3 pictures of the Warriors, Draymond Green might not be one of the 3 pictures you put in there. But it's the best I found when I made this. So just let it be. Okay, come on. Just let me have it. All right, so the idea, though, with the associative property is that you look at these 3 basketball players. It doesn't matter how you're going to group them. You're going to have to deal with all 3 of them at some point in time. So you can think about, Steph and Kevin Durant, but at the same time, you have Draymond Green on the same team. If you were to think about maybe just Kevin Durant and Draymond Green, you can't forget that Steph's still part of that team. So it doesn't matter how you kind of want to, pair them up or something like that, you still have a group of 3. And so this property is A plus B in parentheses plus C is equal to A plus B plus C. And again, the same goes for multiplication. A plus B in parentheses, oops, not plus, let's get rid of that, times C is equal to A times B plus, or not plus, times C, BC. And so when you have 3 numbers and you're going to add them all, you're going to multiply them all, only add or multiply, not both. It doesn't matter which way you do it. You do 2 at a time, and you're going to get the same answer regardless of how you do it. Okay, so now let's talk about the distributive property. This has my personal favorite analogy of all time. So distributive, think about maybe how you have something. I like the idea of like a deck of cards, and you're going to distribute to different players, so they each get, a certain number of cards or something like that. So you can use that as an analogy, but my personal favorite analogy is this, because I tend to think with my stomach, and you'll see why in a sec. Okay, get ready to have your mind blown. So let's say you have a slice of bread right here, and you have peanut butter, and you have jelly. Well, you take the bread and you put some peanut butter on it. You take another slice of bread, you put some jelly on it, and you add it all together. What do you get? That's right, the peanut butter jelly sandwich. You can literally see, the distribution right there. And that's how this property works. You are taking a number, A, and you're going to multiply it by the sum of other numbers. And what you do is you take the A, you distribute it to the B and the C through multiplication. A plus, or times B plus A times C. And so again, what this allows us to do, make that neater, we can distribute some numbers. So let's say we have 2, and then especially if we have a variable in the mix, something like x plus 3, we can distribute this 2 to both of those to get 2x plus 6. 2 times x, 2 times 3. And what this does is it gets rid of some parentheses for us. And so, depending on what we're doing in math, that might be a useful thing. All right, then we have one final property. Unfortunately, this one's not quite as exciting. This one can best be thought of, so it's called the identity property, and you can think of it as like a mirror. There you go. It's the identity property, where you haven't changed the value of something. And so, for example, you could have, there's 2 versions of it. A plus 0 is equal to A, and then A times 1 is equal to A. And actually, this guy right here is something we use with fractions all the time. So let's say we did 1/2 plus 1/4. Well, according to rules of fractions, you have to get a common denominator. And so we want to put these in fourths. Well, the 1/4 will stay as 1/4. But to make that 1/2 1/4, you're going to times it by 2 over 2. Take a look at what we did right here. 2 over 2 is equal to 1. We just did this, but we've disguised it. We've made a costume for our 1/2, and we've made it 2/4, so that way we can add it to the 1/4 to get a total of 3/4. So that's the identity property, and that's one that we've been using. You've been using for a while now, probably. So that's half, or not really half. That's a good chunk of equivalent expressions or equations where you're using these properties. The other way you can see some equivalent expressions or equations are with something called like terms. And so it helps to define what a like term is. And so like terms are variables raised to the same power. All right. And the analogy I love to use for this is apples and, oh, that's a bad banana. Sorry about that. Bananas. Okay? If you had 3 apples plus 4 bananas, that doesn't equal 7. Because it equals 7 pieces of fruit, but these are 2 different pieces of fruit. You can't combine them. It doesn't matter how many bananas you add to the apples, you're still going to have 3 apples. And then likewise with the apples, no matter how many you add to the bananas, you'll still have 4 bananas. Now, what this means in terms of algebraic expressions is where we have something like 3x plus 4. We can't combine that any further. But we add something like 2x, now we have something that's the same because it's the same variable raised to the same power. And same thing would be said about 4, which is technically called a constant. You bring in another number, another constant, it's the same thing. And so these guys buddy up, and we can combine them. And then it's what I like to call finger math. You have 3 of something plus 2 of something, gives you 5 of that something, and then you repeat the process with 4 and 5. You have 4 of something plus 5 of something gives you 9 of something. So we'll wrap things up by going over a couple of examples. And what it's all about is writing equivalent expressions. So number 1, 5x plus 3 minus 2x. So this is one where we're going to we're using several properties. So first of all, we have to identify like terms. Those are the only like terms we have. And then we're going to use the commutative property. So we're going to think of this as 5x minus 2x plus 3. And then we'll combine our like terms to get 3x plus 3. And box it and walk away. Second problem, negative 6x plus 4 times 3 plus 2x. With this one, we need to use the distributive property first. So we'll get negative 6x plus 12 plus 8x. Now, if we want to, we could use the commutative property, or we could just realize we have negative 6 of something, and we're going to add 8 of that same something. That leaves us with 2 of those somethings plus 12. We'll box it, walk away. And then the final example I have for you, x squared plus 2x plus 1 plus 4x squared minus 5x plus 9. Now, you might think you have to distribute, and you're partly right, but it doesn't really matter because this is just a positive one, so it's not going to change anything. So all we have to do is look for like terms. And this is where we have to keep in mind, same variable raised to the same power. X squared and x squared are like terms, but they're not the same as 2x and negative 5x, or as 1 and 9. And so sometimes what I like to do is do like an underline and do shapes, do multiple underlines, something like that, to identify my like terms. Because one way a teacher can trick you is by arranging these in a different order. So to make you think, like, wait, is it actually, or make sure you're paying attention and you combine the right things. So anyways, finger math again. 1 of something plus 4 of something is 5 of that something. 2 minus 5 is negative 3. 1 plus 9 is 10. And there we go. So equivalent expressions just helps us manipulate things. If we wanted to, we could reorder some of these things. We can swap some of the pieces. But it just helps us manipulate the expressions or eventually equations in a way that's useful for us. So good luck with your practice and your homework, and let me know if you have any questions.